Well, hey everybody, it is Friday. Happy Friday. Good morning, good afternoon, good evening, based on where you are. My name is Brandon Satcham. This is not the normal channel that I appear on. I normally appear on my own Twitch channel at Brandon Satcham. But today, I am excited to welcome you to the Particle Twitch channel, where we have done a couple of streams so far that have largely been interview focused on just talking to various folks around Particle. Today we're going to do something a little bit different. And I want to say good morning to the folks that are in chat. Hey James, hey Robert Tables. Both of you, Robert Tables, wearing your Particle shirt. That's awesome. Hope you're maybe wearing the socks as well. But thank you both for joining in. And Third Coast, absolutely. Third Coast, thanks for jumping in. Thanks all three of you for following the Particle Twitch account. Excited to have y'all a part of the stream today. And yes, hashtag soldering mat. So I do have the soldering mat here in front of me that I use as a display surface for my devices as well. So we're gonna have some fun today. The reason why we are here on this glorious Friday morning is because we're going to talk about Particle Workbench. Particle Workbench is a new Visual Studio Code extension pack for working with the Particle ecosystem. So everything from creating projects to doing local and cloud compilation to toolchain management to snippets to on-device debugging, the whole deal. I have about 90 minutes set aside today to spend some time with you all walking through all of those things at a high level. We'll dig deep in a couple of areas. I am happy to dig deep in the areas that you're interested in, or the areas where you might be having problems or challenges, things like that. That's what we're here for. I have a huge list of stuff that I want to go through, but I am more than happy to answer questions, take feedback, really anything that pops up. So please feel free, ask questions in chat. I want this to be interactive. Appreciate the folks that have already been in chat today saying hello. And we're gonna go through this. If you're watching a replay, either on Twitch or on Particle's YouTube channel, you can also ask questions via comments, and we'll keep an eye on that. You can also find us on Twitter at Particle up top there. You can find me on Twitter at Brandon Satcham, same as my handle for Twitch as well. And in either of those places, happy to get any questions that you might have. So what I'm going to be doing today, and the first thing that I want to say is also going to be the last thing that I'm going to say at the end of our stream, is that if any time you're working with the Particle console, or the Particle Workbench, or any other Particle products, there's always two places that you can go to get help if you ever get stuck. The first is docs.particle.io. It's always a great resource, and there's everything in here from quick starts to reference materials, data sheets, the whole deal. Nearly anything you need is in there. So always go. Almost always have a tab open, multiple tabs sometimes, on docs.particle.io. So that's always a great place to go and get help. The second place is community.particle.io. So this is our community discourse channel. Sign up for an account here if you haven't already. There is a fantastic community. The Particle developer community is over 165,000 developers strong. And there are, chances are, if you're having an issue, it's an issue that either someone has encountered before and there's a documented solution, or there are folks in the community that are willing to jump in and to help. We have really an amazing group of folks that are always willing to answer questions and help. And there is a dedicated category for Particle Workbench as well. So as we're actually going through that today, there actually is a specific category for Workbench related issues and challenges. So that's another great place to go. So let's go ahead and get started with that. As the preface to what we're going to be doing today. Installing Particle Workbench, you have one of two options. If you are someone that doesn't already use VS Code and you want to use Particle Workbench, you can go to particle.io/workbench, click the Install Now button, and there are installers for Windows, Linux, and for Mac. That's great. That process actually goes through the entire process of installing Visual Studio Code for you and installing the Particle Workbench extension pack. So that's really easy to use if you haven't used Visual Studio Code before. If you are already using VS Code, the installation is even easier. Really, all you need to do is you can either download the extension from the Visual Studio Marketplace, or you can open the extension tab and search for Particle. I uninstalled it this morning so I could walk you all through the exact process of going through and installing it. And let me actually turn off my desk webcam here so you can see my sidebar fully and completely. I'm going to install Workbench. Now what you want is the extension pack. You'll see three things that pop up, or four things that pop up. Snippets, core, and themes. And those are all parts that can be installed separately. But the Workbench extension pack itself gets you everything that you actually need there. And the installation should be relatively quick. And once that installation is complete, that's right. Now that Visual Studio Code is updated where you no longer need to reload everything, I don't think I actually need to go through a reload. And I should be able to actually open up the command palette. And, oh yeah, so I actually have Particle Workbench. It is now, you'll see a little particle icon that shows up in my right-hand sidebar here. I can click on that to open up the Particle Workbench welcome screen. The welcome screen has quick overview of the basic things that you can do with the Workbench. We'll do all of these things today. Everything from creating new projects to targeting devices, doing local compilation, flashing, etc., all that good stuff. And then at the bottom, there's a ton of help here around learning the various pieces of Particle Workbench. As you're going through this, a great resource that I recommend checking out is actually the Particle docs around Workbench. So if you go to docs.particle.io and you type in Workbench, there actually is an entire set of tutorials around working through Particle Workbench. So if you go to, gives you sort of a high-level overview of the welcome screen, everything that'll show up, all the different commands, dealing with dependencies, installing libraries, all the stuff we're going to go through today is all documented pretty comprehensively here as well. So definitely check that out. What you'll notice when Particle Workbench first installs, like a lot of libraries, I'll move myself out of the way. There's this little hide on startup button right here. This is hidden by default. So you'll see this the first time you install Particle Workbench, and then it'll go away and won't come back up again. You can always relaunch this welcome screen by just clicking on the sidebar here if you need it. But the most important part of working with Particle Workbench is using the command palette, which is not all that different from most other extensions. The command palette is Command-Shift-P or Control-Shift-P, depending on whether you're working in Mac, Windows, or Linux. So if I type Command-Shift-P, that opens the command palette, which if you're already using Visual Studio Code is probably something you're using quite a bit. So every command in the Particle Workbench command palette uses the particle prefix, right? So this is a quick way of seeing everything that's actually possible, and there's a ton here to actually use with Particle Workbench. When you first install Workbench, the first thing that you're actually going to want to do is actually log in with your Particle account. I'm already logged in. So hey, Grogard, welcome, happy Friday. Hope you're doing well, and thanks for saying hi in chat. I'm already logged in, so actually let me walk through the process. Let me go ahead and log out real quick so I can log back in. Log out. I'll log myself out. Keep the current authentication token. You'll notice that the Particle CLI popped up here. This will actually come back. I'll mention this again in a little bit, but I'm actually going to now log myself back in. And my username is Brandon at particle.io. And actually go get my password real quick. All right. And because I have two-factor authentication, you'll actually see this pop up as well. So I actually need to go into my two-factor authentication app on my phone. So this is actually a nice piece, and we highly recommend password 123. That's right. And yeah, security ops strong. We highly recommend actually using two-factor authentication. I'm actually going to move this off my screen for just a moment while I enter my token. But you'll actually see that works well inside of Particle Workbench. You don't need to decide not to use two-factor authentication because you don't want to work with the tools. The two-factor auth works inside of the works in the command line interface as well. So now that I'm logged in, and I can always verify if you're working with multiple accounts, another extension or another command that you can actually run inside of Particle Workbench is the Particle whoami command. And the whoami command in the lower right hand corner it says this is I'm logged in as Brandon at particle.io. So yeah, thanks Robert Tables. I like the auth flow and all within Visual Studio Code, definitely. I've seen a lot of auth flows in the past where it pops open a browser. If you're in a command line experience, you sort of got to go to a browser and then come back, and it's really nice when it's integrated within the environment itself. So that's really useful. So we talked about the command palette before, and get used to that set of keystrokes, Command Shift P, because you'll end up using that a great deal. And there are a ton of commands here, but one of the things I'm going to show really briefly, just as sort of an FYI, you don't have to use these, is you may have noticed that in the extension, when we installed the extension, there was actually also a mention of themes. So the Particle Workbench extension does actually include a couple of different color themes. Matter. No, why did it not do that? Let me try to just have my window reclose on me. Color theme. There's a few. Let me close my Visual Studio Code window and reopen another window. Yeah, Third Coast. Of course, you got to have a theme. You got to have themes with these things. So let me show really briefly. There's Matter, and the Matter theme is sort of the light theme. Gives you sort of a particle darker blue bar and then a light center. I think that's the one we may stick with for the stream today. There's also Dark Matter, and Dark Matter uses the lighter particle blue on the bottom. You'll see it's almost the exact same blue as the logo. It is the exact same blue as the logo. So you are welcome to use the either of those, or keep your existing themes. And a lot of people are very partial about the themes that they have. So we're going to use the Matter theme today. Kind of like the way that it looks, and we'll start with that. So now let's get to the good stuff. Let's actually talk about creating. And Grogard, I'm with you. I actually prefer dark mode on everything too. Nord, that's a good one. I like that, James. Yeah, I prefer dark mode on everything too. I have noticed when I do presentations and whatnot, I think lighter tends to be easier on the eyes with projectors. But I do prefer the darker themes. I'm gonna go with light today to keep. I got a lot of dark around the banners and whatnot on the live stream here, so I'm gonna keep it light here in the center of the screen. The Third Coast, my eyes feel like they're bleeding if they're not in dark mode. I understand. That's how I code all day long. I totally understand. And on my regular streams on my Twitch channel, I do dark themes with everything. So let's actually create a project. There's two different ways. If you're using Particle today, there's two different ways that you will work with getting a new project into Particle Workbench. Both of those, again, rely on using the command palette. So I'm going to go to Particle Create New Project, and when I click on this, the first thing that it's asking me is, tell me where the parent folder is for where this project is going to live. If you're like me, you likely keep all of your development work in a single folder on your machine somewhere. I do all of mine in a folder called development, no surprise. But I do all of my particle related work in a subfolder called particle. So that's the one that's already chosen. So I'll choose my project's parents folder, and then I'll enter the project name. And it's going to ask for confirmation. Do you actually want to create it here under development/particle/stream blink? I will say OK, and it will go through and initialize the project for me. The initialization does a couple of things here. It creates a README by default. This is a README that's auto-generated by Particle, regardless of how you create a project, if you use the CLI or something else. And this README just walks through some of the specifics of what's actually in here. So if you've not worked with Particle before, that's kind of helpful to figure out actually how to work with these new projects. There's also a project.properties file. Project.properties is sort of our Particle's version of a package JSON, if you're familiar with Node, the Node ecosystem. It is metadata about the project, which will come in. We'll see this again in a little bit, but for right now, it's just the name of the project. There's other things that you can put in here, like the description, devices supported. We have on our docs sort of a laundry list of the kinds of metadata that you can put inside of here. There's a VS Code folder. The VS Code folder has a couple of different things. It has a launch JSON, which we'll look at when we do debugging later, and it has a settings JSON. The settings JSON file is where we will save things like the actual devices that we want to flash to and all of that. So you'll see that change in just a little bit. And then the good stuff is actually inside of the source file. Now, by default today, Particle Workbench creates .ino or Ino files, similar to the Arduino ecosystem. There's a couple of things that you can do here. We are going to provide in the future the ability to automatically create .cpp files. That tends to be what I do. I prefer to work with C++ extension files for a number of different reasons. Ino files give you the ability that you don't have to do forward declaration of functions at the top of your sketches, at the top of the source and all that kind of stuff. Right now we create Ino files by default, so you can actually either come in and rename that file if you prefer, and just change it to .cpp and everything will just work as it did before, or you can keep it as an Ino file, and that's great. What's in here by default, not really much to it, and I'll actually, I'll amp up the text here just a little bit, is just the loop and the setup. If you're familiar with doing other forms of embedded development, these should come as no surprise. And thanks, Robert Tables, I appreciate that. I'm glad you're enjoying it so far. This is fun to finally get a chance to go through. So yeah, I'm enjoying it. So when we create a new project, we have the ability, we've got setup and loop. We're off to the races. That's great. Now there is another way that you can actually create or actually get a project into Particle Workbench as well. Third Coast. The background music is actually Pretzel. As Pretzel Rocks. So if you go to the word pretzel, like the food, .rocks, that's where the music is coming from. So you can also use existing projects and import those. A lot of us, when we're working with, I've been working with Particle projects for 4+ years now. Many of us have stuff that we've already worked on, and we don't want to just sort of manually copy and paste source in. So it actually is possible to import projects into Particle Workbench as well. So let me actually walk through this in a bit of a sample here. And let's say that I've created a project inside of the Particle Web IDE build. In this example, I'm just going to take the Blink and LED project, which I think I may already have one. Yeah, I already have a version of this. So if I have it's not that one, hold on. I'll take the simple Blink and LED project. I'm going to use this example. And so I have this project, it's inside of Particle build. I want to use this for Workbench as well. Or I have another project. And so if I have a project in build, what I can actually do is I can download the source for this. There's a button here next to files called Download App Sources. Yeah. So Robert Tables, James, that's why I wanted to show you guys this. This is actually sort of a secretly launched feature from several months ago, where you can actually take existing projects and pull them in. So let's do that. I'm glad that you guys are finding this useful. I've been doing a lot of copying and pasting code in the past as well. So I'm gonna call this, and I'm gonna put it inside of my development particle, and we'll call it link demo.zip. So I've downloaded that into the right place to where I wanted it. I'm gonna unzip that directory. So it's just an Ino file right now. I'm just downloading the application source. And so I can actually, let me right click on this. I'm gonna create a new folder. Here. Now pull that in. I forgot that it just does the individual source file. So I have the source file, the .ino, and what I'm going to do now is I'm going to run Shift Command P, and I am going to do particle dot import project. And I am going to go to blink LED. Oh no, I don't have a project properties file there. So maybe this actually, all right, back up what I said. While it is possible to download the source, you do actually need an existing project with a project properties file before you pull it in. However, that's really easy to do. So let me just really quick. I am going to add, I'm just going to add a project properties file. Let me reveal this in Finder. So this is a bit of a hack I'm doing here, because I did forget about that specific piece. Call it blink LED. All right. So now what I'm going to do is import project. And that's the key. So, and actually, you know what? This is probably where it wasn't a really good example for me to do a basic Blink program, because most of us are going to have projects that we have, like libraries that we're using for and things like that. And if you have libraries that are defined in the Web IDE, it will give you, it'll actually download not just that individual file, but it'll download the library references as well, right? So for instance, if I were to add another library to this, or add any library to this, I would get not just the .ino file, but a project properties. And then at that point, the part of this demo that I just showed that didn't work actually would work. So I went back through importing. Now I have my project properties file. And what it does at this point is Particle Workbench will actually pull in the right things. So, yeah. So sorry about that. Yeah, that was a bit of a demo flub on my part. But that is how you can actually get existing projects in. And if you had an existing project that you were working with before Visual Studio Code and Particle Workbench, and you were using Particle's old Atom-based IDE, Particle Dev, it works. It would work in a very similar way. I know, right, Robert Tables? I didn't make the appropriate sacrifice to the demo gods. That's right. That's right. So what I am going to do here, I'm going to add a folder for source, because I do prefer having that. But once I have that, I have the same blank code, and I'm gonna remove all this heavily commented stuff here. And all of this is just a simple blank code that actually is inside of the examples that shows up in the Particle Web IDE if you're working with a project for the first time. As we did before, I can, and that's commented, that's no big deal, it's fine. I can come in and change this, rename this to .cpp if I prefer, which I do. And that's great. Could be worse, like one of those awkward product demos in the product. Oh, I've been through those before, James. I've been on like keynote stages with those demos before. Those are kind of crazy. Okay, so now that we've gotten through that, that's creating projects, importing existing projects. Another piece of, a few really sort of pro tip pieces of the story with Particle Workbench that I really love, and is one of the reasons why I love Visual Studio Code to begin with, is Intellisense and Snippets. So I want to spend a few moments actually talking about those. The Intellisense side of things is really, I think, one of the most phenomenal aspects of working with modern development environments is that you really don't have to go and look up docs all the time for every single API that you want to use, that you actually can get some help when you're in the midst of writing the code itself. And so a few of the very common things that people use in the particle ecosystem are what we refer to as particle primitives. So publish, subscribe, functions, and variables are referred to as particle primitives. So if I wanted in my setup to add a particle function, I actually can get, I actually can get Intellisense. Well, I had Intellisense for a moment. I can actually get Intellisense here, and actually it's showing me the snippets right now, and I wonder why it's not loading Intellisense. Let me open up my other project. Open that one back up. Go back into this original one. So if I want to use something like anything in the particle, come on. It's recognizing it. Let's look at something like digital write. Here we go. James, this is one of those product demos that just isn't working off the top of the bat. So let's come back actually to Intellisense and Snippets, because I think there's one thing I might need to do first, and that is actually make sure that I have tool chains installed. And this is an important piece of working with Particle Workbench. If you've ever done any sort of embedded development before, you may have jinxed me, James, it's okay. If you've ever worked with any form of embedded development before, you know that installing a local compiler tool chain can be an absolute horror. It can be a nightmare. If you work with ARM-based devices, if you work with different kinds of embedded devices and you're doing local compilation, you can have tool chains that kind of tend to stomp on one another with different versions of the GCC compiler, other things as well. So what we've done in Particle Workbench is that to keep your local environment clean, Particle Workbench actually installs the local compiler toolchain in a particle-only folder. So there's a folder at the root of your environment that has those tool chains, and they're organized by the versions of the device OS firmware you've installed, so you can have multiple tool chains installed at once, and it doesn't mess up any other local tool chains that you may have installed for different kinds of boards and things like that. We find that to be really useful. When you install Particle Workbench, there actually is, not messing with your existing stuff, because we know that there's a lot of people that are working with embedded devices that are working across multiple different environments, and we want to encourage that, and we think that that's really useful. We want to stay clean and respectful of other people's environments. So the installation of Particle Workbench does actually come with a tool chain installed. And the way that you can find your local compiler, install others, is to use the Particle install local compiler toolchain command. So you'll notice that I actually have a number of tool chains already installed, because I've been, as I've been working with this off and on over the last several months, there are tool chains for every version of the device OS firmware that we support. Some of these are marked specifically by individual devices. So there may be a version of firmware, an earlier firmware that only targeted the electron or the photon, or that only targeted the third generation devices, the argon, the boron, and the xenon. You have access to install all of those different tool chains. And so if you want to install a new tool chain, like for instance here, Device OS 101 RC1, which I don't have installed, I'll click on that. It will go and download the tool chain. You get a update right here on the bottom of the screen as it goes through the process of installing that tool chain, and it will let you know when it's actually done. Now, one thing that's important to note is that these libraries or these tool chains can be really large. I mean, GCC compiler tool chains. And hey, RW Shearer, how you doing? Thanks for coming in on this Friday. Hope you're having a great week. All these tool chains can actually be quite beefy. They are, or husky, I suppose. They can be very large and take up a lot of hard drive space. And you can run. A lot of people don't realize that just installing these one after the other. It's nice that they don't step on each other. But if you don't need one, I would recommend actually using the particle command and doing uninstall local compiler toolchain. So regularly, when you know there's something you're not using anymore, for instance, I don't need this version of Device OS 070. It's been a while. I'm not using it anymore. So let me go and uninstall that toolchain. And that actually works pretty fast. So uninstall toolchain, I can go back. Like this one I just installed. I know that I'm not going to need it, 101 RC1. I'll go ahead and remove that as well. So that can be really useful. Another thing that you can do, and like I mentioned earlier, I was noticing that Intellisense and whatnot wasn't working. Really? I was the first person to pronounce your name correct? Oh, what do I win? That's awesome. I'm happy. I'm happy about that. So if I try particle publish again, so I'm having the snippets work. Okay. So let me show snippets really quick and then I'll show something else. I love snippets. So snippets are actually another aspect of working with Visual Studio Code and working with other environments. Many of us just get used to shorthands for the kinds of things that we want to do. And so there are a ton of snippets inside of the Particle Visual Studio Code extension. And a lot of these are accessible, you can see, just with the letter P and then the kinds of things that we're actually, that you might actually want to do. So these are things like working with different aspects of the Particle Device Cloud API to doing things like publish and subscribe, all of this kind of stuff as well. So for instance, if I actually wanted to do a particle function, then I just type PF and tab, and I can write the name of the function, and the function could be turn on LED. And then my next thing to do is actually specify the name of the function, turn on LED, and I'm good to go, right? And that's really useful, but when I'm working with a particle function, I also need to create a function handler. There needs to be some sort of function inside of my firmware that goes through receiving that message from the Particle Device Cloud. So I can do PFH, which is the particle function handler. And this has the right signature for what I need to do. So turn on LED. I can pass in, change the name of the command parameter if I want, and then just start working with my code here. So what I'm actually going to do is I'm going to do a digital write. Actually, let me see if I get that Intellisense back for a digital write. No, that's okay. We have a snippet for digital write as well. Let me see if I can get it to come up. Tab, no. Now it's shown, digital write. And I'm gonna write to the D7 LED, not that. The D7 LED that's actually built in on every particle device, and I'm going to set it high. I'm gonna delay for half a second. See if it works now. And now digital write is working. Sometimes it takes things a bit to catch up. D7, and low. So you'll see the snippets actually, if there's a limited selection, right? When you're doing a digital write, you've only got two options, 1 and 0, high or low. So the snippets are actually making sure that you can choose between those as well. So we'll set that one as low. So, and Gentile Panda, I don't know if it is like Gentile Panda, I don't know if I'm pronouncing that correctly. What is IoT? Yes, it's a great question. IoT stands for Internet of Things. It is a broad term that is designed, or a term that was created to signify constrained devices that can be connected to, controlled by, accessible from the internet. So these are devices that often have Wi-Fi or cellular radios inside of them. And the reason why they are important is because IoT devices, and this is not putting connected things and devices for the sake of connecting things just because, but IoT devices enable us to do things with connectivity, with the cloud, with mobile and web apps that wasn't possible when you were building embedded devices that were just when devices were dumb or disconnected from the internet. So great question, I appreciate it. Robert Tables, the timing when suggestions pop up is configurable in a few ways in VS Code. You may just have a longer delay. Oh yeah, that's right. I need to make a note to look into that. I might have a longer delay. And Robert Tables is right. The S in IoT stands for security. That's right. Absolutely right. So those are those snippets. Snippets are very very powerful, and they make it easy to replicate the kinds of things that I use, particle functions and function handlers and all this kind of stuff inside of my my firmware projects all the time. So anytime you want to use one of those, type P, and you've got really a lot of different things available inside of that. Now, if you want to see more about the snippets that are actually there, and of course we do accept pull requests for these as well, if you have other snippets that you think are useful to add. The Workbench snippets are listed here inside of the actual extension itself. So there's a lot of things in here to do things like I said, work with the Particle APIs, but also working with Particle Publish, working with the new Mesh APIs, working with things that you tend to do in firmware projects all the time, like running digital write, read, analog write, read, things like that. So that can be really useful. Now, and the same goes for Intellisense. So let's say, for instance, if I wanted to, I was trying to get this working earlier, and I don't know why it wasn't. So let me try again. Particle. I'm missing my Intellisense there for some reason. So what I'm going to do now is I'm actually going to show an interesting sort of, if you ever run into a situation like this with VS Code, with Particle Workbench, there is a command that you can use to make sure that you've got everything configured properly to see if there's anything that pops up that might be an issue. Because the fact that we're getting these little red squigglies is, we shouldn't be getting these little red squigglies here either. Things were properly configured. So you can do particle audit environment, and we'll see what we actually get here. In the audit environment, just make sure that you have a tool chain installed. It just takes a look at sort of what you have. This can be really useful when you're actually, if you need help, if you're trying to get help from the particle team. So, this may actually be something that you would need to take and copy into a support request, something along those lines. This does have sort of the full list of where your home directory is, all this good stuff. James, what is security? What extensions you have installed, so that the team can actually figure out what might be a potential issue for you. So, but yeah, you'll notice here that And let's actually look at this. So this is an issue that I haven't encountered in a while, but actually getting Intellisense, yeah, an audit helps a ton to see what you've got, and also submitting bug reports. Yeah, thank you, Robert Tables. That was what I was trying to say inelegantly because my mind was already going somewhere else. I'm actually going to go into the particle community here because I think it's useful to use this. The fact that Intellisense is not working for the moment as a way of just sort of seeing what the community has out there. And if there's a way that I can potentially see a fix for it. So here's a great question that came from October of last year. Here are my steps. Open Workspace. Problems I get include errors detected. Launch with disabled extensions. So it looks like, let's scroll down here a little bit and see. Oh, you know, this actually might be, and this is from late last year, so I don't think this is relevant to sort of a new issue, but I think this may be a problem with actually how I configure your Intellisense settings. So yeah, so the Particle Workbench actually uses the Microsoft C, C++ extension, which is where Intellisense primarily comes from. Oh, here we go. I think this is what it might be, right? The fact that I'm getting a squiggly on this is not a Particle Workbench issue. It's a C toolchain or a Microsoft toolchain issue. But there actually is a C, C++ reset Intellisense command. So I'm going to go ahead and run that. So C, C++. Yeah, reset Intellisense database. So we'll see if that actually does it for me. And failing that, I'm just gonna kill Visual Studio Code and bring it right back. So let's just do that. But I mean, that's the kind of thing, this is why having this community can be really useful. And yeah, Robert Tables, I know I've been having a couple of issues trying to get some things working. So using audit environment could be really useful. And then also, if you run into a problem and you want to submit a bug report, having that audit environment output in the community can be really useful. And it looks like that actually fixed the issue for us. So we're not getting red squigglies anymore. I think this is just an issue with me uninstalling the particle extension and reinstalling it for the stream. I think reloading, and when in doubt, restart Visual Studio Code. Reloading Windows can still be really useful. So I should actually get Intellisense now. So let's try this again. No. Oops. We try Digital Right. That's something there for a second. Well, I have done something. Hey, Frackberg, thanks so much for the follow. I know you as well. I'm on a different channel today, but hopefully it is going to be just as much fun. Let me reset that Intellisense database again. What's my quick fix? No code corrections are available. So let me go back, scroll down here a little bit. See if there are any issues with my No, it seems, no, it's fine. It's correct. Let me disable the C, C++ Intellisense thing and re-enable it. Cannot. Oh yeah, that's right. I can't disable it because the particle extensions depend on it. That's all right. Intellisense will come back up at some point. I don't want to belabor that because I actually want to get into flashing some code on a device to actually get it on on an actual device here that is not pointing to the device on my desk any longer. The webcam went ahead and fell. So I have a particle device on my desk, and what the next step, and I have some code. I actually want to put it there inside of Particle Workbench is to actually use the particle configure workspace for device command. Right? Nope. So particle configure project for device. Excuse me. So I'm going to choose a version of the device OS firmware that I want to use. I'm going to use, where is it here? 1.2.0 beta 1. This is going on an Argon. This device here on my desk here is an Argon. And the name of the device, maybe absolutely certain to get it right, is Workbench Demo. Workbench Demo. So now that I've configured the device, and you can also, I don't know, you can see at the bottom, you can also access that information on the bottom here as well. So you can always change those things by just clicking on one of these items in the bottom toolbar. The name of the device, the target device, etc. All of that stuff that's in there, that actually can all be changed. Oh wait, I see, maybe I missed a notice there. Intellisense database set. Oh yeah, no, those are just other things. So James, it's kind of weird going to the Particle site and seeing so much real world stuff when my whole experience watching, playing, and learning with Particle has been in this maker hacker space. Obviously it's awesome though. Oh yeah, totally. And I get it. I mean, yeah, that's been a big part of my experience as well. It's been just in messing with things and trying to build makery kind of projects, but that's kind of fun. And it's neat to see when people take these devices that we work with, these same devices, and just do amazing world improving cool things with them, which is very nice. So now that I've configured the workspace, I've configured my project for this device, there are two things I can do. I can compile and I can flash. And when I'm compiling or flashing, there are two different ways that I can do that. I can either compile the device, I can either compile locally or in the cloud. I can either flash locally or in the cloud. But now that I've set up my device locally, one thing I want to show very briefly is if you go back in this Visual Studio Code settings JSON file, that's actually set here as well. So if you ever need to actually see where the actual magic is happening behind the scenes, that's set here in the settings JSON file. You can change it directly in there as well if you prefer, if you forget the commands, anything like that. But now that I've configured things properly, I want to go ahead and compile. Now, doing a cloud compile, just like it sounds, actually is the same as running a cloud compile inside of the web IDE. The device firmware is compiled on our servers. Same thing with doing a cloud flash. Building local is one of the new features. One of the new things that Particle Workbench enables is you can do local builds on your own tool chain with your own tool chain, which I think is actually is pretty exciting. So the way that you do that is, again, Particle, Command-Shift-P, open the Particle command palette, and Particle compile. You'll see a couple of different options here for compilation. You'll see compile application local, cloud compile, compile application and device OS, and compile application for debug. These are different and you use them for different things. The three local options, compile application just compiles this code that's on the screen here in front of me. This is just my user firmware. That's all it compiles, and that's all that's in the binary, so that when you flash to this device, it keeps the version of the device OS that's already on here. And your project is built based on that, hopefully same version of device OS. If you want to, for some reason, compile both the application and the device OS, it does both. Given the version that you have set down here at the bottom, right? I've set 1.2.0 beta 1. It compiles that version of the device OS using the local source and your application, packages those up together, and they're ready to go. Or the final option is compile application for debug. So if you're actually going to do local debugging on your device, you need what we refer to as a monolithic version of your firmware. You need a monolithic binary. The monolithic binary has your firmware, the device OS firmware. Really, it's everything in one giant binary. And that's what allows you to debug not only your application, but to be able to step into the device OS, things like that, which we'll look at in a little bit. Right now, I'm actually just going to do a local compile. And the local compile actually will open up a terminal window, and it just runs the make command for me. And it's freaking out. How's it freaking out? All right, so here's, this is another one of those things to do when things get weird, if things ever get stuck, which I may have gotten myself in a weird place because of uninstalling and reinstalling the extension. Another thing that you can do is you can actually run the reset environment command. Reset environment will uninstall your local compiler toolchains and reinstall them. This may take a little while, so I'm going to take a look at chat here for just a moment. Frackberg, looking at stuff always makes me feel a little dumb, as my big idea was turning on likes in my living room. Hey, that's where we all got to start somewhere. I usually start in places like that, James, right? And they're using it for sensors or something in a business critical scenario. Absolutely. But yeah, you got to start. It's good to start somewhere. In Frackberg, I did hook up a Pi to alert my brother if it thinks his sump pump has failed. Oh, that's cool. That's really neat. The preventive maintenance or, predictive maintenance kind of stuff is always good fun. I like that. Oh, actually, I think I dirt myself. I know what my problem is. While that's downloading the toolchain. I think I did this to myself by renaming .ino file to .cpp. .ino files, when we compile them, we do a lot of stuff behind the scenes to add headers and other things without you having to declare them explicitly. When you rename a .ino file to CPP, those things no longer happen automatically. So there's a few things that you have to remember to do when you use those. And one is that in order to get all of the particle headers and all the particle stuff actually working, you need to include the application.h header file. That has all of our stuff in it. Robert Tables, I started with a light via Twitch, and now I'm trying to hook it to the OBD2 port on my car. I love that kind of stuff. And I love the ideas that come out of working in this sort of environment, because I was actually driving back from giving a talk in Dallas yesterday, and I had like another half dozen ideas for projects that I want to build using the hardware. Stuff for streams, stuff to just sort of make my life easier, work around the house, things like that. And I'm excited about that project, Robert Tables. Hopefully today helps, so that for tomorrow's stream, your stream tomorrow, that'll be kind of fun. I'll be there so we can help, so the chat can help you out with some of that. Frackberg, so that putting together the voltage stuff, definitely. All right, I'm still downloading tool chains here. Oh, James, you definitely should check out get a car loop device. They're really cool. Really, really cool devices. Alexis Bacam, thanks so much for the question, and hello. Hope you're having a good Friday. Do you have any plans to do a tutorial on how to use an external SIM in the Boron? Good question. We're currently working on solutions for the monitoring of electrical equipment in bank agencies. We use a boron 3G, but we need to use an external SIM in some places. Alexis, that's a great question, and I think I absolutely could do that. It's not something that I have on my current list, but I'll add it at your request. I think that that would be a cool thing to do. For those of you that may not be aware, the Boron, one of Particle's new third generation devices, actually has an eSIM built in. So you, unlike the Electron, you don't actually need to use a SIM. We provided the SIMs with the Electron, but there's a built-in eSIM that's in there. You can use an external SIM, and what Alexis is asking is that we do some tutorials and docs on how to actually go about doing that, because it absolutely is possible. So yeah, great question. I appreciate it. I'll make a note to do that for sure. Robert Tables, this is helping so much. Thank you. And thank you for showing me there's a Particle Twitch channel. We should chat offline. Oh, yeah, for sure. And I want to do, we would love to do more on this channel for sure. See, there you go. Yeah, that's right. Frackberg James. There's a real world example right there. Alexis, and also, Alexis, if you want to, and I don't know if that's your first name, apologize if I'm not, if it's different, but feel free to email me, brandon@particle.io. I would love to help out. And if you want to do that as a sort of a reminder to do the tutorial, that would be super. So I think it's downloading and installing all my tool chains, but I don't have that doesn't need to stop me from actually trying to do a local compile here. All right, so now that I've fixed it, it's going through the local compilation process right now. These not a Git repository commands are normal. You'll see those when they run through. But the ultimate command that's running is just a make command. Hey, .commie. Thanks for coming in and dropping in the swag from the hype from my other Twitch channel. I appreciate that. I hope you're having a good Friday. So while that builds, let me actually now show you that Intellisense was working all along, and I just derped myself. Yeah, all right. Now Intellisense is working. So I said this now like 3 different times, but I love Intellisense. Everything that we have in the device OS firmware that's exposed via APIs, you have Intellisense for. Everything in other libraries you're working with, anything like that. So if you're working with particle variables, you can see what the template looks like. You can actually see where it's defined, etc. You can see the signature that it expects for a variable. You can actually right-click on a API and do peak definition and actually see how this is defined inside of what we refer to as our wiring API. So the Spark wiring cloud is where a lot of the particle primitives are defined. So you can see you can see the source code for how we actually define the variable, the variable primitive, the cloud, or the function primitive, and publish and subscribe as well, which is really, really cool. I love Intellisense. And again, I've been working with particle stuff for 4+ years, but I love having this level of insight into what's actually happening underneath the covers. And we'll see that when we get to debugging in a little bit as well. So that's Intellisense, now actually working. My build is still doing its thing while toolchain installations are happening. So while that is going on, I'm actually going to go and open another project. Oh yeah, I got to reload the window. Okay, so I'm going to do that. I don't know if that's going to kill my make. It might. Oh, and I lost my music. I don't know what happened to my music. 1 second. I'm going to get music coming back up. All right. All right, and you'll see this message sometimes too. I don't know if this was supposed to come in. The only music we need is happy little devices doing happy cloud things. It's true. It's very true, Robert Tables. You may sometimes see the message to install dependencies. That could be if there's an update to the Particle CLI. One thing I meant to mention earlier is that Particle Workbench is an abstraction layer on top of other tools like our device cloud, like the Particle CLI, etc., which is really useful. It keeps things clean. We're not fragmenting the development experience in a ton of different places. But sometimes if those dependencies change, we need to install a new version. So I'm going to go back into the command palette now. Oh, what was that? No. Go back into the command palette and do particle dot compile application local, which is what we were doing before. It should be a lot faster now than it's actually going through it. The first time compilation could take a little while with any new device. They tend to get faster with recompiles. If you've already sort of built the binary, you've done, it can build an intermediate step. This one was pretty quick because the project is actually relatively small. But you'll notice here that once I actually do that compile, I now have a new directory in here called target. So when you do a local compile, you do get out the other end the actual resources that you need to do basically to do a local flash if you need to. The bin directory itself, you get a bin with the CRC and no CRC versions as well. So you get you get the object files; those are actually included if there are any in here as well. So you get that target directory. That's for local compilation. I mentioned earlier, if I actually did a local compilation and I did compile app and device OS, I would get two binaries that would show up in this target directory. If I did compile application for debug, I would get a much larger binary that shows up in here as well. On the other hand, if I did a cloud flash or a cloud compilation, let's do a cloud compile. If I did a cloud compile, that's actually taking place in the Particle device cloud. So there's no tool chain that gets installed in that case. And it gives me a bin in a different location. It actually will download the bin right here outside of the target directory. So that's one of the ways you know you're working with one versus the other. James, question about devices. I'm using an ESP8266 for monitoring plants. I want to swap over to the Particle. Is the Xenon the smallest and cheapest board for this? And is there a way to buy it without the pins? Or is it an unsoldered job? An unsolder yourself job? Yeah, so James, Alexa's recommendation, the Photon is definitely a great option. I would recommend actually using the Argon, using the Wi-Fi device, because that is the equivalent. However, if you're wanting to use the ESP, if you use the ESP8266, you want to use the Xenon in offline mode, that's definitely possible. And today we actually don't provide them with the solder, without pins and castellated edges. So you would have to desolder the Argons yourself. To Alexis's point, if you wanted to get one with castellated edges, the Photons you can buy without the headers, and you could just use that, and that would totally work just fine. So I'm going to go back. I'm going to take a look at my list here. So that's the cloud compiler. We talked a little bit about the local compiler as well, and the three differences of why you would need one versus the other. And the other piece is cloud flashing and local flashing. If you want to do local flashing, which I tend to do a lot when I'm doing very fast iterations on devices, the first, actually, let's look at cloud flashing first, because there's nothing you really need to do. That works the same way the same way it does today, using the Particle device, or using Particle build, the Web IDE, CLI, etc. So if I want to do a cloud flash, I actually get, oh my camera, I wonder if that's me. So the flash message is popping up sort of behind where the screen is right now, or where the where the device is right now, but you'll actually see as the flashing starts that my argon is actually going to start blinking magenta actually as it receives that update. Or maybe it is. We go into the console and confirm. It's one way to know that flashing is actually taking place. So let me try that again. It says it's doing it. Let's try doing local flash first. I should have gone with what I said I was going to do. So let's do that. Local flashing requires you to do something slightly different with your device. You actually want to put it in DFU mode, or device firmware update. And the way that you do that is you hold down both of the buttons on the device, and then you let go of the reset button while holding the setup button down. It'll start blinking magenta at first, which is safe mode, and then it'll start blinking yellow, which is DFU mode. And when your device is in DFU mode, it's basically listening for certain kinds of serial commands to do a firmware update locally. So I can actually now do flash local. So flash application local. And that's going to do a build. Again, it's going to do another make very briefly. And then it's actually going to run some DFU commands in the console to set that device accordingly. So it says that it set it. But because this is a new device, it may actually be useful to go ahead and do a local flash of both. Flash the application and the device OS. So I'll go ahead and do that now. Because a lot of times when devices come off the factory, like we update the particle device OS a lot. There's a regular cadence of updates, and so if there's a new version of firmware, a new feature you might need, or a bug fix, then you would want that on the device, a newer version than what's actually on the device coming from the factory. And so it is possible to do the local flash and get both your user firmware and the device OS firmware jumped on there or flashed on there at the same time, which is what we're going to do now. And this runs a different command. It's going to take a few more minutes. So a few more moments. So while that does that, I see Alexis has a question. Last week I was working with a Seed Studio sensor for its quality and easy integration with particle, but some sensors do not have particle libraries. I had to modify a library for the sensor, Grove infrared temperature sensor array, and adapter for use, which you have in the catalog. Oh yeah, okay. So the question is there a way that this modified library can be uploaded in the particle catalog? For the solution that we have to work in the company, it's not recommended. Alex, absolutely. Shoot me an email, definitely, and I can help follow up. But in the particle docs, we actually have a contribution guide for creating firmware libraries. So if you go into the docs and you go into, I believe it's in reference. Well, let me just search real quick. Search for contributing libraries. We have a contribution guide on creating firmware libraries. I spelled something wrong. Yes, I did. Yep. Contributing libraries. And inside of this section, there's some example on how you can actually create, submit your own libraries for public use or even for your own internal use. So definitely check that out. And shoot me an email if you have any questions or anything like that. All right, so it's still doing. So here, this is taking a while because the flashing process, or because the actual compilation process of the device OS firmware, it's big, right? There's a lot that actually needs to happen. While this is happening, one thing that I want to share is that you may have noticed at the top of Particle Workbench as well, there's actually these 4 different buttons that pop up when you install it. If you hover over them, you can see there's compile and flash and then call function and read variable. And those are all available outside of, or from here as well. Now for compile and flash, by default, this actually does cloud compile and cloud flash, but you can actually change those. So if I go into the settings for Particle Workbench, if I go into my settings and I look at extension settings, and then I go to Particle, there's a number of different things that you can tweak here in the settings. So Adrian Hall, hey, thanks so much for the follow. Hope you're having a great Friday. Thanks for coming in. Oh, Robert Tables, yeah, no question. Sorry, no problem. You have to put the device in DFU mode to do a local flash. Because you basically need to put the device in a stop state so that it can receive new firmware. So because I'm actually doing a local compile and flash, you actually need to do this piece first. So, no worries. Yeah, I think I do believe you do follow my other channel, or my channel. But yeah, thanks again. So Robert Tables, the way that you do that is you actually hold down. I'll do it again because it's not flashing right now. You hold down the setup and the reset buttons, and you let go of the reset button until the device starts flashing yellow, and then you can let go of setup. And at that point, it's in DFU mode and it's ready for local firmware. That's only for local. For cloud compilation or for cloud flashing, that's not necessary. So settings, these are important. So inside for the particle extension settings, I mentioned that the compile button does a cloud, or actually local app device OS by default. I was wrong. But you can actually change this to do a cloud flash or a cloud compile, a local app compile, the app and device OS, or the debug version. And those are the choices that you can make. You have some other options in here, like disabling the welcome screen or enabling it, verbose compiler logging if you want it, name of the firmware you're using, the firmware version you're using. The same thing is with compile, the flash button, the action you want it to take, and then your default platform and all that good stuff. So that's a useful thing to do if you ever actually need to go in and change any of those types of things. So this local compile is taking a while, which can happen. That's why cloud flashing is so nice, because we put it on the big beefy servers, and you don't have to wait for your machine to do all that work. Jamie HB, hey, thanks for the question. Thanks for coming in. Sorry if you already answered this, but is Particle going to add the ability to upload all libraries and files directly to the web IDE? That is a good question. You're talking about if you're working with let's say you have a folder and you want to put it in the web IDE. You don't want to use the offline IDE. We don't currently have plans to support that inside of the web IDE today, but we certainly could take that feedback and see if we could potentially prioritize that for sure. I think right now what we are really focused on is trying to make sure that the Particle Workbench is the best offline development experience for building IoT solutions. So a lot of the attention has been put on really making sure this has the polish that it needs. Is there a reason why you all are looking at using the web IDE for such a large project as opposed to using a tool like Workbench? Hey, BS Calaro, how you doing? You're having a good day. Oh, cool. Thanks, Robert Tables. Thanks for making that clip. All right, so the cloud flashing, the DFU flashing is actually happening here behind me. I'll scroll up a little bit, and then that was the second DFU mode update. So this was the DFU flash for the main device OS, and then my user firmware was flashed here secondly as well. So now I am breathing happy cyan, and my device isn't really doing anything. But we do know that there's a particle function here that I can actually call. So that was my web flash. That was, using the local local compilation in Flash I mentioned earlier. So let me actually make a tweak to this. I'm going to change this to be, oh, not toggle. We'll just see. We'll just call it LED on. So I'm going to change that function name, and now what I'm going to do instead is I'm going to do a cloud flash. So when I use the cloud flash option, which I tried to do before, I think it still was waiting for the latest DeviceOS firmware. What happens at that point is all of the work of doing the compilation, contacting device, and all that actually happens in the cloud. This happened pretty quickly. I went to Magenta. Now the device is restarting. All of that stuff was taken care of for me. I didn't have to wait. It's done. That change happened. You'll notice now it came online very quickly, and if I take a look at the functions on the device, I see I have an LED on function now here as well. As I mentioned earlier, these buttons allow me to do those things. So I can call LED on. I will hit enter, and I have no argument here, but if it works, I don't know if you saw that. It was very quick. I'm gonna hold it up just a little bit. The blue LED on the top of the device will come on for about half a second. Oh, no. What was that? So function, LED on, no argument. Sure. Did I miss it? But you'll notice what's actually happening here under the covers when I use that button is that it opens up the particle CLI inside of Particle Workbench. I mentioned before that the Particle CLI, the Workbench leverages existing work, existing functionality that we have, existing tool chains. And so it's really useful. You always have the ability, you can use those the IDE buttons, you can use that UI, or you can actually jump in to the Particle CLI and use these commands yourself, right? LED on. And I can run those commands inside of the CLI. If the CLI is closed for any reason, you could always reopen it. Again, everything is inside of the command palette. Particle, there's a launch CLI option. You can launch the CLI. You can also launch the compiler shell if you need to interact with a GCC compiler. That's an advanced use case that I'm not going to cover here. You can always launch the CLI. And if there's a terminal open, it'll ask you if you want to reuse it, or you can create a new terminal window here as well. The Particle CLI, if you've never used it before, has a lot of these same functionality. Has a lot of the same functionality that you see inside of Particle Workbench, and you can see what's available with the Particle Help command. And there's a ton of good stuff there for listing devices, calling webhooks, setting up webhooks, generating tokens, all that wonderful stuff inside of there. Oh, Robert Tables, you saw it? Cool. Yeah, maybe it's just me, but Cloud Flash seems very smooth and fast. I don't have to put it in DFU mode, very sick stuff. It is. Cloud Flash is really easy. Now, to be fair, it's not apples to apples in what I did before, because what I was doing before actually required me to also build the entire DeviceOS, because this was a new out-of-box device from 2 days ago that didn't yet have the latest firmware or the latest DeviceOS firmware. So I had to go through that part of the process as well. But if I were to do the same thing again and to do a local flash, and so remember, local flashing in this case, this button is configured to do a local flash. So I'm going to do that right now. It'll be fast. It should be a lot faster than it was the first time. It goes through and it does the build. And then DFU mode, it'll go through, yeah. So it only took, less than 30 seconds. 10 or 15 seconds, maybe even. So that's pretty cool stuff. The other thing that I haven't talked about too much here, but is useful, I do a lot of serial debugging when I'm working with devices. You can use particle primitives to do things like cloud or like, function, variable, things like that. But a lot of times what we end up doing in embedded projects is doing work in the serial monitor, right? So I may do serial begin 9600, and then I want to do, it's common inside of a project that I may do a serial.print line. I do this to log status as my projects are starting, or I do it to debug or inspect the state of variables as well. That's a hot flash. I guess you also don't need internet access for a local flash, so probably it's good in the field. Yeah, for sure. Oh, and Jamie, I missed your comment earlier. Easy way to maintain sensors once they are in the field. It's a good question. Can you shoot me an email? Because I would love to hear more about what y'all are doing. Again, Brandon@particle.io. I would love to hear more about y'all's use case and see what we can do to potentially help. Definitely. So if I have a device that actually is using the serial monitor, what I can do is use the particle console to launch the serial monitor automatically, and then it gives me the option to automatically reconnect or not, which is nice. I will create a new terminal for that. The command that it runs is, again, it's also the particle CLI, but it runs this particle serial monitor command, and then the follow flag basically says watch for restarts. As the device restarts, just go ahead and continue to follow it. Now I have a couple of argons connected to my computer right now, and so if you have multiple, it'll ask you which one you want. So I'll choose this one, and I will restart it, at which point I should lose the connection. Oh, looks like I picked the wrong one, which is okay. It happens. So let me open up the serial monitor again. Great. I'm at my serial monitor. When I restart, it's attempting to reconnect. Serial monitor open. And then my started command comes out. It has been printed out to the terminal. So you can do serial monitoring inside of Workbench as well. You don't have to have a separate tab for that. Now, that's all very interesting, but one of the things that I have been really excited to do more of lately is actually debugging. But before I get to that, because right now what I do is serial monitoring tends to be sort of my default way to debug. I think we all kind of tend to do that from time to time. It's sort of the console log of the embedded world is using serial print and things like that. So what I want to do is show debugging, but before I get to that, I want to talk about libraries because the question has come up. Alexis had asked the question about libraries. I think if you're ever doing anything of consequence with a piece of embedded hardware, you will eventually need to use a library. So the way that you install libraries is, again, using the command palette. There's a few different things that you can do. If you don't quite know the library name that you're looking for, you can run find libraries command. And so, for instance, maybe I'm looking for a library by Adafruit. I can't remember exactly what it's called, but the name is Adafruit. That will actually run the library search command in the command line interface, and you'll get a list of libraries that Adafruit libraries, or at least a short list of Adafruit libraries. Robert Tables, color red is the console log of the UI world. That's right. What happened to printf being the base? You know, I like C. I like C++ better. That's all right. That's just me. I'm not hardcore enough. So you can find libraries using this as well. When you find the library that you want, you could run the install library command. Install library, and then in this case, let's say I'm going to install the Adafruit GFX library. Not GFK, GFX library. And when I run that command, that will actually go and pull down the library. It'll install it for me, and that will create a new folder called lib. It'll install the library right there inside of my lib directory. It gives me the sources, I get examples, all of that wonderful stuff as well. So I can start to use those, add the includes, and sort of go off to the races. One thing that's important to note here is that sometimes when you're using a library, you may make modifications to it. If you're developing a library that you plan to contribute, this may happen. If you make a modification to a library, the way that compiling and flashing works is slightly different. When you compile or flash locally, the Workbench will use the library that's installed locally. When you compile or flash in the cloud, Workbench will use the cloud-based version of that library. And the reason why that matters is because when you install a library, it also modifies your project properties to add dependencies. So this metadata file now knows that this library or this project depends on the Adafruit GFX library. So when I do a cloud compile, it doesn't send my local library up. It sends my local source, but it doesn't send the library. It pulls the library from our repository and it does the compilation. But when you're doing a local compile, it uses that local library, which is pretty cool. Okay, let's talk about debugging, because this is the fun part. This is actually something that I have been really excited to show off, and I think it's a good way to end this stream. Yeah, BS Claro, it is the exact same version. The only difference is that if I were to come in here and I make changes to the Adafruit GFX header file, like I change a constructor or something like that, and then I do a cloud compile, it's not going to use what I changed locally. So as long as you're not changing libraries, it doesn't matter. It's the same version. It all works great. The other thing that's important to note is you can actually install specific versions of libraries. So for instance, if I wanted to install the NeoPixel library, I can actually do an at 0.0.3, right? And actually just specify I think there's an 0.0.3, and it specifies the exact version. So it can go and grab a specific version of the library as well. And you'll see that now that's been added here. And if I look at the library properties file, it is the 0.0.3 version of that file, or that library, even though there's a newer version that's actually out there. So, debugging. Let's look at this, because this is actually pretty exciting. Inside of the Workbench tutorial, there's two different tutorials on debugging Workbench. The 3rd generation devices and 2nd generation devices, like the Photon or the Electron. You can use the exact same debugger for both. There's just a little bit of difference. You have to do some manual wiring to the Photon and the Electron. I'm not going to show that off today. Those docs are out there and they're really good. What I am going to do today, however, is show debugging on the Argon. And I'm actually going to start by plugging in my particle debugger. And then I'm going to plug it in to the JTAG header that's actually on the Argon itself. Makes this whole process way, way easier. And then from here, what I'm going to do is I'm going to open up a project. So if you go into the, or if you look at the Workbench guide, we recommend actually using the tinker break as we go through this. So that's actually what I'm going to do now, because I think it's a good example of easy debugging. So I'm going to open a project that I have here. And that has the tinker break source. I'm going to remove this. Now I need to run configure workspace for device, just like I did earlier. So I want to make sure that things are actually working. Configure project for device. I'm going to use 1.2.0. This is an Argon, and then again, Workbench demo is the project. So now that I'm connected, and this is important, you want to make sure both of these have to be separately connected to USB. So this debugging only works via USB at this point. So my Argon's connected to USB, the debugger is connected via USB as well, and the debugger is connected to the Argon. I can actually click on the debug tab, or click on the little debug icon. BS Claro, green screen and standing desk at home. Are you in the office today? I'm green screening it, and I am at home. I am at home. And you have a couple of different options here with the debugger. There's the debugger we're using today, and there's also a programmer shield. So you would choose the option accordingly. I'm using the debugger with the Xenon. So I'm going to choose that option. And then what I'm going to do is I'm going to actually put my device back into DFU mode. This is how I start the debugging process. Once I'm in DFU mode, oh, sorry, not DFU mode. I want to put my device in safe mode. And safe mode is the same process as DFU mode, except you let go of the setup button while the device is blinking magenta. So before it starts blinking yellow. Oh no. Well, that was a quick aside on how to get your device into safe mode, but I really did need to do DFU mode, so forgive me. It's Friday. I give myself a break. It's Friday. All right, so now that I'm in DFU mode, I'm gonna click the green button to start the debug process. And you'll notice, as we've seen in the terminal before, that things are happening. There's a build that's taking place. What's happening at this point is when I mentioned the local compilation options earlier, is that it's going through and it's actually doing a complete build of the particle, a monolithic build of my application plus the device OS firmware. So it's putting the whole thing on there, which is going to take a few minutes. And you'll see it'll take a little while, but as it goes through it, and that actually is an important thing to note. When you're doing debugging and you get that monolithic piece of firmware on your device, it's going to put your device in an odd state if you want to go back to just doing cloud flashing or compiling only of your application source. Because the monolithic piece of firmware is much different than what we refer to as the hybrid firmware, where we can put just your device OS changes or just your application, your user application, onto the device. So there's a process for getting it back into a state where you can do cloud flashes, et cetera, and all that too. Robert Tables, it looks like the Photon doesn't have plugs for that debug cable. No, it doesn't. So Robert Tables, let me show you there isn't a JTAG header on the Photon. So what you end up having to do in this case is you actually need to use 3 pins. You actually have to connect. You can use the same debugger. It's the exact same debugger, but instead of using this wire, what you end up doing is you connect a common ground, and then you connect the D7 and D6 pins on the Photon to the SWD IO and SW clock on the debugger. But once you've done that, everything else works exactly the same. Everything else works in precisely the same way once you've gone through that. And y'all, so bear with me while this is actually building, because it actually does take a little bit. But I think this is a good thing to kind of end with. Like I mentioned, while we're waiting for that to build, I will say the same things that I said at the beginning. That is, if you're working with Particle Workbench and you ever get stuck, 2 great places to go are the docs and the Particle community. So community.particle.io or docs.particle.io are always great resources for getting help, for finding other folks that are working with or having the problems you're having. Like I mentioned, there's a whole section for Particle Workbench that is available here as well. A great place if you're actually as I was having issues with Intellisense earlier. Turns out that they were my issues with Intellisense, not any issue with the extension itself. The team is very active on this channel. Matt Morand, who is the primary engineer behind Particle Workbench and an amazing engineer, is in this discourse channel all the time, answering questions and helping people out. Other folks on our team are there all the time as well, so definitely check that out. And then, of course, as I mentioned earlier, the docs. The Workbench docs in particular are really, really quite comprehensive in terms of all of the commands that are available, how to deal with dependencies, how to work with your projects, what they look like. A lot of the things that we went over today, dealing with Intellisense, the themes, how to handle key mapping. So if you actually want to do key mapping for existing editors, like you're a Vim or Sublime person, and you want to make sure your key maps are there, and you're new to Visual Studio, all of that stuff is in there as well as a walkthrough of snippets and settings and all that good stuff. There's actually also a resource here for migrating from the Web IDE, changes between the Web IDE and Particle Workbench, and also the old Atom-based Particle Dev IDE and Workbench as well. So definitely check out those docs as you're going through Particle Workbench. And we got a little time. I mean, this is the last demo I'm going to run, but if there are any other questions in chat, comments, suggestions, feature requests, let's talk about it. I'm just waiting for this build to happen right now. The good news is that this build is a one-time kind of thing. Once I don't have to wait for this every single time I need to debug locally. That would be crazy. Once I've actually gone through and done this, and if I make changes and want to go back in and re-debug, that whole process is much faster moving forward. The reason why this is happening is because I went back and put hybrid firmware back on here, and now I'm putting the debug build on here again. Robert Tables, are there other people you know of streaming things with Particle? Well, there's you, which I'm excited about. No, at this point, so I've talked to the Michael Jolly about it a little bit. I'm going to be on his stream on Sunday, and we're going to talk about potentially using Particle for some of his stuff. I believe that NoOpCat has in the past, but oh, Jamie HP, you do as well? Awesome. I'll have to check out your channel. That's perfect. What kind of things are you streaming? We should all give you a follow. So I'm gonna check out your channel and see what you're building. Yeah, I would love to see more folks building stuff on streams with Particle, because there's a lot of cool ideas and opportunities out there. Hey, that's all I do is tinkering. That's all I do. Most of the time, it's fun. All right. We're getting there, y'all. So a lot of what you're seeing in these errors, and these errors will be resolved, but it's just going through and actually building. The process of building the monolithic firmware is a time-consuming process, because there's a whole lot in FreeRTOS and everything that we've done in wiring, and all of those things as well on top of that. Robert Tables, another question: can you address the cost of Particle Cloud and where the delineation between dev and enterprise fit? Yeah. One second. So that's a great question. A lot of, we have Particle hardware and the cloud software priced in such a way that you could use it. You could use the Particle tools in the Particle cloud for a long, long time in a maker, tinker, hobbyist sort of context and never have to pay. I believe the last time that I looked at the first 100 devices in the device cloud are free. So until you get to that point that you've added more than 100 devices to the cloud, it's completely free. And in terms of the new mesh-based products, mesh micro networks are free, up to, I think, 10 networks or something like that. So micro networks are networks that have a single gateway, like an Argon or a Boron. and an unlimited number of Xenons as end devices, and those are all free as well. So you can do a lot. You can go a long way using these products without having to pay for the cloud product or pay for the cloud services or anything beyond that. The enterprise conversation is a different one. If you're starting to look at multiple gateways, argons and borons, like you need failover in a network, or you need networks that are much larger and more distributed, or you need fleets of hundreds or thousands of devices. We have public pricing on the website. I don't remember at the top of my head, but at that point, it's more of a conversation with the sales team about what people are doing. BS Clara, what did I say? What did I say? What was that reaction for? Are you commenting on how long this is taking? Because that's what I'm thinking inside my head. I want to show y'all this. I want y'all to see this because the debugging stuff is awesome. We're just being forced to wait for it. Just forced to hang out and wait for it. Oh, awesome freeness. Yeah, absolutely. And the build. Yeah. I feel like we're close. I want to say we're close. I know, because this isn't like... Oh, is it really? Particle console is down, Jamie? Well, good thing I'm doing a local build then. Robert Tables, this is where we're supposed to be sword fighting in the hallway, right? This does evoke those old... This does evoke the old... crud. Why am I blanking on it right now? The webcomic. I know what you're referring to. It's also where your name came from. XKCD. So, yeah, it is the old, like, oh, compiling. Sword fighting. Yes, sword fighting while compiling. Yeah, XKCD. I don't know why I blanked on it right then. And back down. Yeah, Jamie, I saw that earlier in the particle community. If we had something on the status page about the console. Oh, things are okay. I saw a status earlier today where there were some intermittent console issues if you had multiple tabs open, like a lot of different tabs open. Yeah, .com deploying on a Friday. The console seems to be working for me, Jamie. But I did see earlier that if you had a ton of different tabs open, that might potentially be an issue today. Oh, we're getting there. There we go. I'm getting my debugger file, the debugger L file. Cool. Okay. Alexis, I was planning to work with a transceiver NRF24L01 to have a greater working distance between the MCUs. I also thought about working with LoRa. Absolutely. No, you will not have problems with the NRF52840 and LoRa. So for context of the question for folks here on the chat, the new particle devices use a chip from Nordic called the NRF52840, which is a thread certified radio. That's what we do all of our mesh networking through. And this thing keeps falling. And Alexis was basically asking, well, can I at the same time actually work with LoRaWAN for larger distances between mesh networks? But the two absolutely should work together. I have not personally worked with both of them, so I can't speak to how they work, but there isn't any reason at the silicon level why you shouldn't be able to work with both of those at the same time. Yes, now we are debugging. Alexis, you bought me some time. That was a perfect way to slide in there and ask that question. So we got it. So we're flashing. You'll notice that the device is actually now technically, it's turned itself off or it's halted. So I'll just I'm going to actually hit the continue button to keep on going. Device is going to come back online. And when it starts breathing blue, or when it starts, breathing cyan, I know that I'm ready to go. So what I can do now is I can actually launch the particle CLI. and I can launch, I can actually break in and see what's actually going on inside my application. So there are a couple of breakpoints that are actually already in here. Ah, yeah, .commie, I appreciate the kapow for that. I got it working. Oh yeah, so that's an automatic breakpoint that's in here. So I'm going to do particle, excuse me. If I can type at the end of the stream, particle call Workbench demo break. Now I'm calling a cloud function, and that is now stepping into my application. When the device sees the cloud function, it enters this command, and this ASM command is basically just doing a breakpoint in firmware. So it's hard coding a breakpoint. But you'll see that once I actually get in here, I have a view of local, global, and static variables inside of my application. And let me actually go ahead now, and I'm going to turn off the desk camera so we can see the full-on options here. I can see global variables. I can see my call stack. I can actually see where my application got to this point. I got in setup and loop. That's actually where the whole thing started. So I can step back into my call stack. I can see breakpoints that I've created. I can actually take a look at ARM Cortex peripherals and registers. I can look at the registers on the registers in the on the actual hardware device itself. I can inspect memory. I can actually enter memory addresses manually if I know them and see what's actually at that space in memory, which can be useful in cases with or in certain types of firmware development for sure. Now, it's also possible for me to set my own breakpoint. So once I've done this, I can continue. So continue on through, continue. So I've exited the breakpoint. My application is now running like usual. But I can also do different things. So I can set my own breakpoint. So here I actually want to set a breakpoint here on the result of 1,000 divided by whatever I pass into this handler. So this is another function, firmware function. Yeah, buy desk cam. It was fallen anyway. And yeah, Robert Tables, this is cool. I'm really excited with this feature. I'm actually going to use some of this in my next stream on Monday on my channel to mess with some of the LED light wall stuff that we've been doing, because I have some ideas around showing off some of what's going on there that I still need to debug and fix. So it'd be really neat. So now that I've set this breakpoint here, I can actually call this function. So I'm going to do particle. So let me get this over my head. See how I see it? Okay. Particle call, Workbench demo. And the name of this one is div. So I'm going to divide by 10. It's going to execute that cloud function and stop on my breakpoint. Now, I can actually see my local variables here. I can see that the command that I've passed in had a value of div. The div value is 10, and the result that comes out of the whole process is 100. Again, I can see my call stack. What's cool about actually getting to see this call stack, and the reason why you need to do a monolithic build of firmware, is that I can actually step into device OS firmware. The call stack gives me a view not just into my user firmware, but the classes that are inside of the particle device OS and how this entire process got to me, got to my user firmware. So I can step all the way in and see exactly what's happening, all the way from the app loop that runs your application down into the Spark process, the cloud. This was Particle's original name, so we still have some functions and classes that have that name of Spark. So I can jump all the way up into that and then all the way back down into my individual functions as well, which is really, really cool. And I'm planning on using this. Yeah, .commie, absolutely. I'm planning on using this a lot more in my own applications, and hopefully y'all will as well. But just like any other kind of a debugger, you have the ability to step into functions, step over, to actually restart debugging, etc., and all that kind of stuff. So again, this is really exciting. I'm going to disconnect right now because I think I'm going to end it here. Like I mentioned before, This was fun. I figured, I actually wasn't sure I was going to have an hour and a half of stuff to talk about around Workbench, and here we go. We're almost 2 hours in. So I had fun doing this. Hopefully you all learned something. For folks that are watching a replay again, feel free to add comments, ask questions via comments. For those folks that are watching on YouTube or another location, feel free to hit us up on Twitter. Hit me up at Brandon Satcham or Particle at Particle, and check out, watch out for future live streams here on the Particle channel. And if you're interested in more Particle on Twitch in your day-to-day during the week, I stream twice a week, Mondays and Thursdays at my Twitch channel, which is twitch.tv/Brandon Satcham. Other folks here, Robert Tables, who is in chat, streams about particle stuff a lot as well, so definitely feel free to check him out. He'll be streaming tomorrow, Saturday, so you can check that out even as early as tomorrow. So Robert Tables, let's see. So you don't actually need the programmer to do debugging. So what's the programmer board for? Oh, great question to end on. The old school programmer board, like the early version, that was just sort of the first programmer that we created. That was before we had support for the debuggers, for the specific debuggers. I think if I understand your question, but feel free to follow up over IM, and we can I can answer your specific question if I'm not getting it. And yeah, Third Coast, thanks again for hanging out. I'm going to end it here because it's almost 2 o'clock my time. I had a great time today. Y'all have a great rest of the day. Happy Friday. And enjoy the rest of your week. Enjoy your weekend. Thanks, everybody. Bye.